In this video, we're going to be looking at how to divide a rational expression when that division comes out with a remainder. So the sort of division that we've done so far is where you take a look at a rational expression. That's when you have a polynomial divided by another polynomial, and that numerator can be factored. Sometimes it was given to you in factored form, but now that we have those skills, we should be able to turn it into factored form, and what you notice is that the denominator is one of those factors. That's been a telling sign to us as to what we should try to factor by, and of course those x minus 5s would cancel out, leaving you with just your simplified form, and those would be our equivalent expressions for that example. So if we use synthetic division to help us do that work a little bit faster, we wouldn't have to actually worry about the factors. We would move directly to just dividing by x plus 3. Now again, x plus 3 is your denominator. Negative 3 is the root of that denominator, so that's why we put that in the box. And we can just use the coefficients of the numerator, do our synthetic division, we get out a 0. That tells us that negative 3 is a root of that numerator, and you're left with just whatever your coefficients are here. So that means that this expression simplified is x squared minus 6x plus 5. And we could do that with other roots of this same exact polynomial. We knew that 1 was a root, so therefore x minus 1 is a factor. So if you divide by it, your synthetic division works. You get a 0 in the bottom right, and you're left with this expression. Or if we wanted to divide by x minus 5, we know that 5 is a root of it based upon the original factored form of this that we saw. And so therefore, when you do your synthetic division, you get 0 out, and this is the expression you're left with. However, we're not always going to be dividing by something that we know is a factor. You could divide by anything you really wanted. Another polynomial would be easiest. So let's say we switch this problem and we wanted to divide by x plus 5 instead of x minus 5. So this problem looks very much similar, and if this was a problem that was given to you off the bat, you wouldn't know that negative 5 or x plus 5 wasn't a factor of your original expression. So what you would do is you would do your synthetic division like you would with any other problem. So as we set that up, we see that negative 5 goes in this box because that is the root of the denominator, x plus 5. That is easy to find. And then you use your coefficients of your numerator. And so as we finish this out, you bring the 1 down. 1 times negative 5 is a negative 5. You add those together, you get negative 8. Negative 8 times negative 5 is a positive 40. This equals a positive 27. And then when you multiply 27 times negative 5, you get a negative 135. So when you add those together, it actually equals negative 120. We're used to this equaling 0, but clearly it's not, and so we have to find some way to figure out what that means. That value in the bottom right is what we call the remainder. It's what didn't quite get divided out with you were dividing by x plus 5. Again, we're used to this being 0, but that's because up till now we've always been dividing by a root or dividing by a factor that comes from a root. So in order to do this, what always happens is that the root of the denominator goes in the box here. You do your synthetic division. If you get out 0 here, that tells you that you are dividing by a factor. If you don't, then this is just the remainder. And your final answer is just put over that factor. So since we had 1x squared and then a negative 8 and a positive 27 down in their coefficients for the synthetic division, that's what you know you have as your whole values, and then you're going to add that negative 120 over that original denominator, x plus 5. Of course, you could always write that as a minus 120 over x plus 5 as well. To conclude, if you're dividing by something which is not a factor, you will know because you won't have a 0 in the bottom right part of your synthetic division. If that is the case, you can still write your final answer. It's just that you're going to have a remainder portion of your answer at the very end of your polynomial.